When we are working with a finite population, there are often times when we need to collect a subset of the population. We call it a simple random sample. To collect a simple random sample from a collection of data, a population collection, is fairly easy. Here I have the EAI dataset, something you'll be using in your homework, and I'm going to generate a simple random sample using Excel. So the idea of a simple random sample is that I need to choose a subset, but every element in the subset has to have the same probability of being chosen. That was a definition given on page 320. So let's figure out how Excel can be used to choose a random number. First off, there is a function, rand, open parenthesis, close parenthesis. So this is a function, rand. It has no arguments, which is why I just opened a parenthesis and then closed it. It will generate a random number between 0 and 1. And every time I alter things, meaning do another calculation in the data sheet, that will regenerate a random sample. Right now what I want to do is take the 2,500 observations in this data set and assign a random number to each element. So I double-clicked. Let me show that again so you know exactly what I did. I went into this little square in the bottom right corner, and when I got that crosshair, I just double-clicked, and it filled in 2,500 random numbers. So what it did is it copied the function all the way down the column. So you can see it's there. Okay. What I need to do now is set up some sort of a criteria for choosing random numbers. So what if I want just 30? My n, my choice of the number of observations, is just 30. Why don't I do this? Why don't I highlight cells A through D and then just order on the random number? So order on the random sample, smallest to largest, largest to smallest, doesn't much matter. Any kind of ordering will do. So I go ahead and do the ordering. By the way, when I do this, all of these numbers are going to regenerate. But what Excel is going to do first is place the number, the element with the smallest random number in this first row. And then, of course, it's going to regenerate the random number, so how are you going to know that, right? Well, here's what I know. Element number 945 was the smallest element last time around. And that's good enough for me, I believe it, okay? So I want the 30 smallest random numbers to take or choose my sample. Okay. So I just move them over. I don't really need these random numbers anymore. Maybe I'll get rid of them so I don't have to look at them. Well, at this point, I want to use my sample to estimate some of the population parameters. So I have the population parameters already over here. The mean was 51,800 and the standard deviation 3,999.2. Well, why don't I just use this smaller sample in order to construct a estimate of the population parameter? So the average calculated the same way. Average. What am I taking the average of? Close the parenthesis. Out it comes. Notice it's not exact. I have 50,819, which is close to 51,800, but not exact. And I don't expect exactness. We will create a process over the next chapter or two that will help me get an even better handle or better estimate of the population parameter through a repeated process, similar to what we're doing here. Now I can get an estimate of the standard deviation, .s for sample, whoops, probably equal standard deviation .s, highlight the data that I want the highlight the data that I want the standard deviation deviation of, and notice, right, it's not a perfect it's not a perfect estimate of the population parameter, but it is a good estimate of the population parameter. And as we repeatedly take random samples, we will get better and better estimates of the population variances, standard deviation as well. So this is an example of how to collect a random sample. Again, here's the process for every element in my data set. Generate a random number, highlight all my data, sort, custom sort, by the random sample, smallest to largest, largest to smallest, doesn't much matter. And then choose, if you're choosing an N of 30 as the size of your random sample, choose those 30 elements, and then use those 30 elements to estimate the population parameters from the sample. More on this to come later.